Good morning, afternoon, or evening, cats and dogs. Today's video will focus on the solving equations by multiplying or dividing guided notes, including lesson 8.1. We've already talked about solving one-step equations by adding or subtracting, and I think that solving one-step equations by multiplying or dividing is actually a little bit easier. So we're going to talk a little bit about our inverse operations, just like we did for adding and subtracting, although it's not going to be quite as extensive. Eventually, we are going to mix both adding and subtracting and multiplying, dividing into the same equation. And that will be with two-step equations and ones that take even more than two steps as well. So I want to skip over the division and multiplication properties of equality. We did this with adding and subtracting. They basically just say that whatever you do to one side, you have to do to the other, including if you divide both sides or you multiply both sides of an equation. I do have an important note though here in about the first third of the page. It says the inverse of multiplying by a number is dividing by that same number. The inverse of dividing by a number is multiplying by that same number. Why? Because multiplying is not the same as dividing by the opposite, and dividing is not the same as multiplying by the opposite. So what does all this mean? It means that there's only one inverse for multiplying and dividing. So I'm going to highlight that because that's a really important statement. There's only one inverse for multiplying and dividing. The only inverse of multiplying by a number is dividing by that same number. And the only inverse of dividing by a number is multiplying by that same number. So when we did solving one-step equations by adding and subtracting, you were able to change either the operation or the sign on the number. For multiplication and division, we can only change the operation. And the reason why that is the case is because, again, this statement right up here, the multiplying is not the same as dividing by the opposite. Dividing is not the same as multiplying by the opposite. When we did subtracting, we knew that subtracting was the same as adding by the opposite, but that doesn't apply to multiplication and division. So again, when we want to write the inverse or identify the inverse for multiplication or division, the only option we have is to change the operation. So let's look at some identifying the inverse for statements, problems. Number 1, multiplying by -8. The inverse of multiplying by -8 is to divide by -8. We only have the option of changing the operation. The inverse of dividing by 5 is multiplying by 5. That is our only option. Again, we only have the choice of changing the operation. Number 3, the inverse of dividing by 5.68 is multiplying by 5.68. The inverse of multiplying by 1/3 is dividing by 1/3. The inverse of dividing by -4 3/5 is multiplying by -4 3/5. Notice how I'm only changing the operation and not the sign on the number. Finally, the inverse of multiplying by 4.8 is dividing by 4.8. All right, let's try some examples. So numbers 7 and 8 are already done for us. This is on the back of the first page. It says to solve each of the following equations, show your inverse operations on each side. So in number 7, I have 2x equals -8, and I'm still going to list the what's happening to the variable, or WHTTV, and inverse, although I realize that as advanced students, you may not feel the need to show this, and that's okay too. So what's happening to our variable x is we're multiplying by 2. The inverse of multiplying by 2 is to divide by 2, and that's my only inverse. So I'm going to divide both sides by 2. We'll go ahead and highlight our inverse. 2 divided by 2 gets us 1x. That's our goal. We want to solve for x because 1x equals x. What I'm plugging into my calculator to find my solution is -8 divided by 2. So -8 divided by 2 is -4. So our final solution is x equals -4. To check your solution, you can plug this into your calculator. Do 2 times -4, hit equals. Your calculator will give you -8, and that's the number that's on the opposite side. Let's take a look at number 8. G over -5 equals 6. So we represent division with a fraction bar, but remember the fraction bar represents division. So what's happening to the variables, we're dividing by -5. The inverse is to multiply by -5. So we show that on each side. I typically actually show it below instead of off to the side, but you can choose to show it wherever you want, as long as whatever you do to the left side of your equation, you also do to the right, to keep it balanced. So on the left-hand side, we're going to be left with g, which seems a little strange to students at times, but keep in mind when we talked about multiplying fractions before, if I do g over -5 times negative 5 over 1. These little lines, by the way, should actually be shifted up a little bit. I added some things into the guided notes, and it did not move the lines, but it moved everything else. So the negative 5s will cancel out. So this is really where those lines belong. And we end up with g divided by 1, which is just g. And then on the right-hand side, we'll need to do 6 times negative 5 to get negative 30. The reason why I show this over here is just because I often have students who are like, well, does that really cancel out? It does. If you divide by negative 5 and then multiply by negative 5, because those are inverse operations, you're going to be left just with your variable. All right, let's try some examples on our own now. Feel free at any point. There are a lot of examples here. If you feel the need to try some of these on your own, that's fine, but please double check them with the calculator and make sure you have a pretty good understanding of how to do these problems. Also double check with the video. So don't just complete the problems and then move on. You want to make sure that you're checking with the video to see that your solutions and your work are correct. Because I sometimes have students who get the correct answer, but their work doesn't match their solution. So take some time and do that, because I am seeing some students who are trying to do the work on their own. They're making mistakes, and then when quiz and test and graded classwork times come around, they're making those same mistakes. So please just double check everything. Although I do realize that we have a lot of examples here, you may be able to start trying some of them on your own after a few practice problems. So number 9, we have a over 12 equals negative 3. What's happening to the variable is we're dividing by 12. The inverse and only inverse of dividing by 12 is to multiply by 12. So I'm going to show that inverse on both sides. I'm going to multiply both sides by 12. Now notice how I'm showing it down below and not off to the side. It's just a nice way to organize things, but this is where students often think, oh, I need to do 12 times 12, and that gets me 144. But you're dividing by 12, then multiplying by 12, which leaves you with a. What you should be plugging into your calculator to get your solution is negative 3 times 12. And our final answer is negative 36. Now, if I want to check this in my calculator, I'm not going to put it in as a fraction. I'm going to do negative 36 divided by 12, hit equals. It's going to get me negative 3. I'm going to divide and not use the fraction bar. All right, number 10. What's happening to the variable is we're multiplying by negative 5. The inverse of that is to divide by negative 5. So I'm going to show dividing by negative 5 on both sides. And again, don't be afraid to pause the video at any time if you're falling behind in showing your work. So divide both sides by negative 5. On the left, we're going to be left with x. On the right, we need to do negative 25 divided by negative 5. That's going to get us a solution of positive 5. So I want to point out here that this question, the negative 5x equals negative 25, I often have students who try to add 5 to both sides to find the solution here, which is not correct, because this problem doesn't involve addition or subtraction. It involves multiplying by negative 5. The inverse I have to use here is to divide by negative 5. So just be careful here, because I see students do this a lot. They're like, oh, minus 5, I've got to add 5. But that's a negative 5x equals negative 25. We're multiplying by negative 5. The inverse is to divide by negative 5. So be careful with that. I'm going to cross that out so we don't do that, but I've seen students make that mistake quite a bit, especially once we start mixing together equations by adding, subtracting with multiplying and dividing. And actually at the end of this video, I do have lots of practice worksheets for you on this as well. At the end of this video, I'll reference another video, very short video, that'll have some practice with adding, subtracting, and multiplying and dividing. It's not going to be something you have to watch, but I think it's good for you to see some independent practice problems on both add, subtract, and multiply, divide equations. All right, number 11. What's happening to the variable is we're multiplying by 7. The inverse of that is to divide by 7. So we're going to divide both sides by 7. So let's go ahead and show that. In our calculators, we should be doing negative 49 divided by 7, and our final solution will be x equals negative 7. And I'm going to move through these pretty quickly until we get to our decimals and fractions, and then we'll speed up again once we see several of those. Number 12, what's happening to the variable y is we're dividing by negative 4. The inverse of dividing by negative 4 is to multiply by negative 4. So let's multiply both sides by negative 4. And in your calculator, what you're plugging in here is negative 9 times negative 4. And you're going to get a solution of 36. Remember, you can double check this. Do 36 divided by negative 4. Your calculator will give you negative 9. All right, number 13. What's happening to the variable z is we're multiplying by 10. The inverse of that is to divide by 10. So let's divide both sides by 10. In your calculators, you're going to be plugging in negative 100 divided by 10, and we should get a solution of negative 10 equals z. All right, I want to take a close look at number 14 because this one's a little different. Negative c equals negative 15. What I would do is rewrite this as negative 1c equals negative 15. Put a coefficient in front of the variable. Then what's happening to the variable is we're multiplying by negative 1. The inverse of that is to divide by negative 1. So we're going to divide both sides by negative 1. Negative 15 divided by negative 1 is going to get us a solution of c equals 15. Now, as advanced students, what you could use as a little bit of a shortcut is basically just drop off the negative on each side and you get c equals 15. The reason why we see something like this is because in one of our later lessons, we're going to see problems like 9 minus c equals negative 15. And you're not going to be able to just add 9 to both sides. You're actually going to subtract 9 and then divide by negative 1 to get your solutions. And we'll talk about this once we get to two-step equations. But I just want you to recognize that this is a negative 1c, so we divide both sides by negative 1. All right, number 15. What's happening to the variable is we're dividing by negative 15. The inverse of that is to multiply by negative 15. So let's multiply both sides by negative 15. We'll show that right here. In your calculators, you're going to be plugging in negative 6 times negative 15, and this will get us a solution of 90 equals w, or w equals 90. All right, number 16. What's happening to the variable is we're dividing by 8. The inverse of that is to multiply by 8. So let's show multiply by 8 on the left and the right. In your calculators, do negative 3 times 8. You are going to get a solution of negative 24. All right, so we do have to mix in some decimals and fractions. So our remaining questions, please make sure for sure you have a calculator handy because you'll want to double check these in the calculator. So number 17, 3.8g equals negative 9.88. What's happening to the variable is we're multiplying by 3.8. The inverse of that is to divide by 3.8. So let's show that on both sides. What you're going to plug into your calculator to get your solution is negative 9.88 divided by 3.8. Remember, division isn't commutative, so do those in the correct order. We will get a solution of g equals negative 2.6. All right, let's take a look at number 18. In this problem, we're dividing by negative 7.4. The inverse of that is to multiply by negative 7.4. And again, you may be getting to the point where you don't have to write this out, but go through this process mentally to identify your inverse operation. So let's go ahead and multiply both sides by negative 7.4. What you're plugging into your calculators is negative 2.8 times negative 7.4. We should get a solution of j equals 20.72. These are really important for you to double check your solutions. Don't be afraid to take some time once you finish a quiz, test, or graded classwork, or whatever assignment you're working on, and plug these back into the calculator. So you can do 20.72 divided by negative 7.4 to make sure you get negative 2.8. All right, let's move ahead to some fractions. So we have negative 8/9 r equals 1 and 5/27. What's happening to the variable is we're multiplying by negative 8/9. So our inverse is to divide by negative 8/9. Now next year, you might learn that dividing by negative 8/9, we've already talked about this year, is the same as multiplying by the reciprocal, which is multiplying by negative 9/8. So you could also multiply by the reciprocal here, which is negative 9/8. You don't have to do it that way, but I know a couple of years ago when I covered a class for Mr. Drahowski, they were learning this, and he teaches the kids to multiply by the reciprocal instead of divide by the fraction. They're equivalent, they're the same things, but you may see it slightly differently next year depending on who your math teacher is. I'm not sure how Mr. Salzer teaches it, but I just know that when I covered Mr. Drahowski's class, this is what they were doing. So let's divide both sides by negative 8/9. There we go. And you might want to practice plugging this into your calculator so that if you're not sure how to plug it in or you're getting something weird every time, you can double check with me on a day when you're in class and I can help you figure out how to plug it into your own calculator. It's easier to do in class versus online, so make sure that you ask those questions in class if you're not sure how to plug it in. So in your calculators, you should be plugging in 1 and 5/27 divided by -8/9, and you should get a solution of -1 and 1/3. So don't forget to double check that in your calculators. If your calculator gives you a mix or an improper fraction instead of a mixed number, just let me know and I can show you how to deal with that as well. All right, in question number 20, we're multiplying our variable b by -3 and 2/3. So the inverse is to divide by -3 and 2/3. So let's go ahead and do that. Try to highlight all of that. So we'll divide both sides by -3 and 2/3. Really, the work takes longer than anything else. I've taken the time to plug it into the calculator as well. So you're plugging into your calculators -32 and 4/15 divided by -3 and 2/3. So -32 and 4/15 divided by -3 and 2/3. Again, don't be afraid to pause the video to try it on your own before you see the solution, but you should get b equals, let me move all this down, 8 and 4/5. All right, let's move right ahead to numbers 21 and 22. So we've got decimals and fractions here. Number 21, we're multiplying x by 7.8. The inverse is to divide by 7.8. So let's show that on the left and the right. In our calculators, I'm not going to box it in, but we're going to plug in -93.6 divided by 7.8. And you will get a solution of -12. Oddly enough, it works out pretty nicely for us. All right, number 22. -12 equals -3/4 s. What we're doing to our variable s is multiplying by -3/4. So let's divide both sides by -3/4. Do that on the left and the right. And again, you might be hitting the point where this is getting to be pretty routine and simple. So if you want to try some of these remaining questions on your own, just don't forget to watch the video as well to make sure you did them correctly. Plug in -12 divided by -4/3. Sorry, -3/4. Goodness, I'm thinking about multiplying by the reciprocal. And you're going to end up getting 16 equals s for your solution. All right, 23 and 24. We've got 4 more questions to take a look at. Number 23, we have -127.5 equals -0.85 z. What's happening to the variable is we're multiplying by -0.85. The inverse is to divide by -0.85. So we'll do that on the left and right. In your calculators, plug in -127.5 divided by -0.85. Lots of decimals here, so be careful. You end up getting 150 equals z. Number 24, -18/25 equals -1/15 b. So what's happening to the variable is we're multiplying by -1/15. The inverse is to divide by -1/15. Let's go ahead and show that on both sides. Again, what you're plugging into your calculators is -18/25 divided by -1/15. And we will get a solution of 10 and 4/5 equals b. Excuse me. All right, last 2 problems, numbers 25 and 26. So we have -2/3 p equals 22. We're multiplying by -2/3, so the inverse is to divide by -2/3. Let's go ahead and show that on both sides. You're going to plug into your calculator 22 divided by -2 and -2/3, which will get us -33. Finally, number 26, -3/4 b equals -9/20. We're multiplying by -3/4, so let's divide by -3/4. In your calculators, -9/20 divided by -3/4 is going to get us a solution of 3/5. If you're ever getting the reciprocal of the answer, like 5/3, you're probably dividing in the wrong order, so you'll want to double check that. Like I said earlier in this video, what I'm going to do is create a short video for you that includes problems that involve addition, subtraction, and multiplication and division, all one-step equations, just to give you some practice with this. It's not required watching or required of you to complete those practice problems, but it would certainly benefit you. Thanks for listening.